Hello, folks. Thanks for being here for our second weekly webinar. And today we will be talking about the cold snap outlook for this coming fall and winter. And today I have with me an exciting guest who is a specialist, particularly in the stratosphere, which is the determiner of cold snaps. So it should be a great session. So I want to start off, first of all, just by saying a teeny bit about me. I'm an Earth system scientist. I used to be a professor. I used to work for the U.S. Department of Energy in their Office of Science as a fellow focusing on the Earth sciences. My co-founder is an AI scientist, Dr. Kalai Ramea, and we decided to start Planette together because we really wanted to bring some of the state-of-the-art research findings that we were seeing happening in academia and in research circles and really bring them into the real world to make a difference in people's lives, in their business activity, and, in this case, with this audience, for folks that are trading. So today I'm super excited to welcome a special guest, Dr. Aidan Sweeney Jaramillo. Dr. Sweeney is an Earth system scientist. He's a data engineer here at Planette. I love working with him, and exciting for all of us, he is an expert in the stratosphere. So he's going to really go into the nuts and bolts of how cold snaps happen, which are the topic of today's webinar. And the TLDR here is that this is going to be a cold, snappy winter. And so Dr. Aidan will tell us all about that. So as you know, this is a weekly series, and next week we have a really exciting webinar specifically on the ski season outlook for this fall and winter. So be sure to continue joining us at these weekly sessions. So before I get started, I just want to provide a teeny primer on how long-range weather forecasting works. The weather apps that you have on your phone and on, say when you look up your favorite weather forecasting website, these weather forecasts are done using weather models, numerical weather models. They are atmosphere only models, and they generally run max up to 14 days. The reason for this is because the atmosphere pretty much forgets where it started from after 14 days. So this is the maximum predictable power. If we want to predict beyond 14 days, in other words, get into this long range forecasting territory, we really need to use Earth system models. Earth system models are much more comprehensive models. They include not only models of the atmosphere, but also the ocean, the land, and the land ice and sea ice. And these models can provide predictability weeks, months, years. If you look at the deep ocean has centuries of memory. Not that anyone usually asks about that, but that would be possible. And so this is what allows us to predict beyond the usual 14-day time horizon. Keep in mind that whenever we forecast beyond 14 days, the forecasts are usually not day to day. So usually we can forecast week to week, month to month, season to season. And by doing so, we can provide real important insights on how the fundamentals of the Earth system are going to be playing out to influence weather patterns at that time. So I can't tell you if you're going to have a snowy Christmas day, but I can tell you whether the likelihood for snow is high at your location in December because of the prevailing weather patterns. So today we're going to look at the long range outlook, specifically in terms of cold snaps. We'll talk about what cold snaps are, and then Dr. Aidan will talk about the physics of cold snaps and why the atmospheric fundamentals really favor these cold snaps this year. And a hint, it's all about the stratosphere. So he will go deeply into the stratosphere today. And then after that, I'll just do a quick review on the state of the MGO, which really gives us some good, fine subseasonal predictability. So predictability from the end of that 14-day window all the way up to about 6 weeks into the future. So we'll really be looking into October 2025. And there's some really nice insights there that I want to go over. And I'm echoing a lot of what I went over last week. So the forecast really hasn't changed in any of these regions. And because of the clear MJO signals here, I think that we can consider these to be pretty robust outlooks. So, to begin with cold snaps, first of all, what is a cold snap? A cold snap is just an abnormally colder than usual weather condition for a particular location. And these cold snaps, they can occur pretty abruptly and they can persist for days or even weeks. And so you can imagine that the longer that some of these events happen, the more impacts there might be on the ground, including disruptions. As Dr. Aden will be telling you, these cold snaps are really strongly linked to major excursions in the jet stream that are due to polar vortex weakening events. And so he will tell you all about that. But also, I want us to keep in mind that when these events happen, once again, they're linked to major disruptions, major market disruptions. This includes an energy infrastructure, including natural gas infrastructure. Pipes freeze, wells are inoperable. There's a lot of disruption in the energy sector that comes with these cold snaps. In addition, there are agricultural effects. There are major effects in shipping and logistics. For example, say in shipping of natural gas at Russian ports during a Eurasian cold snap. So these cold snaps, not only are they interesting from a meteorological perspective, but I guess everybody is probably here because of how they're very interesting from a market perspective. So from here, I'm going to pass on the baton to Dr. Aden, who will tell us all about the physics of cold snaps.
Yeah, thanks so much, Dr. Hansi, for allowing me to talk a little bit about this connection between the weather and the extremes that we see here on the surface of the Earth during the winter season in the Northern Hemisphere, and how those are actually connected to a very remote region of the Earth's atmosphere, which is called the stratosphere. So the stratosphere is the second layer of the Earth's atmosphere, and it starts at about 10 miles above the Earth's surface. When we're in the northern hemisphere wintertime, the air over the in the stratosphere over the northern hemisphere polar region becomes incredibly cold. And once we have this very, very cold air mass, that air is also begins to rotate very, very quickly. So in the figure on the left that we're looking at here, this graphic is actually showing this stratospheric component of the polar vortex at the top of the globe here, right above the Arctic region. You can see in these squiggly lines this very rapidly rotating mass of cold air. So typically what happens is during this winter season, we have a relatively stable polar vortex. And when we have a stellar polar vortex, we tend to observe other characteristics in the atmosphere, for example, a pretty normal or pretty close to average polar jet stream. So the polar jet stream is another ring of air which circles around this polar region, but it's not to be confused with the polar vortex. So these are actually distinct phenomena in the Earth's atmosphere. But although these are distinct, that doesn't mean that they're not connected, right? So we can actually see that when the polar vortex undergoes the stratospheric polar vortex undergoes some type of weakening, that can actually lead to major excursions of this polar jet stream. And when we have this really, really wavy polar jet stream or large meanders of this polar jet stream, what that allows is for air, which used to be concentrated in the Arctic region over the North Pole, it allows that to spill to much lower latitudes. And when we have this Arctic air that gets pulled to these much lower latitudes, that's when we start to experiencing these events, which are referred to as cold snaps. So we know that the stratospheric component of the creation of these cold snaps can actually be quite important. So on this figure on the right, we're seeing exactly this. So that previously very stable vortex turns into a disrupted polar vortex where the main vortex splits into these two smaller sister vortices. And when that happens, we have these really large meanders of the jet stream and cold snaps over the US and also over parts of Eurasia. Okay, so I think we're ready to go to the next slide. So one of the things that you might be interested in knowing is what are the actual temperature patterns that are associated with these weakenings or disruptions of the stratospheric polar vortex. And typically, what we observe after we have one of these awakenings is one of two different temperature responses. So the first temperature response, which is typically associated with the largest deviations in the strength of the stratospheric polar vortex. So when this thing either breaks up or gets pushed very far off of its main axis over the North Pole, we tend to see really strong negative temperature anomalies over Eurasia. So highlighted in the blue box on the left in temperature response one, you can see that there's this broad band of decreased temperature that's extending from northern Scandinavia all the way out until eastern Asia and eastern Russia. So this is probably the most canonical or most well understood of the temperature responses that we get from having this stratospheric polar vortex disruption, but it's not the only one. And another flavor of how these temperature anomalies can actually play out is something related to temperature response too. So we've actually seen this in some recent polar vortex events that I'll talk about in just a moment. But when we see this second type of temperature response, we tend to get very deep and very cold temperatures over the northern United States as well as Canada. So these temperature anomalies can extend very, very far south over the continental US and are actually linked to some of the really intense cold waves that we've seen over the Texas region, especially the Texas cold wave of 2021, in addition to a lot of the severe weather outbreaks that we saw associated with blizzards in the January of 2019. So both of those were associated with temperature responses to stratospheric variability, which resulted in very, very strong cold snaps in the manner that we see in temperature response too. So, because we can look at all the historical events when we had these polar vortex disruptions, we can see that there's associated temperature responses which appear to be more favorable when we actually have these disruptions, and thus we can come up with these types of maps. Okay, so I think that we're ready for the next slide here. So, typically, when we're talking about the predictability of one of these cold snaps, most of the dynamical models that we use are kind of limited in that sense. We might be able to only get, a couple weeks of predictability before we know that one of these cold snaps is actually going to happen. However, that is not to say that we can't say something about the state of the polar vortex, even with many months out. So even though right now we're sitting in September of 2025, we can actually know that it's probably very likely that this winter, so the December of January of 2025 all the way until February of 2026, is likely to experience a much weaker than average polar vortex. And the reason for that is because of the covariability that the polar vortex has, with another much more predictable oscillation in the Earth's atmosphere. And that oscillation is called the quasi-biennial oscillation. So this is actually a reversal, which happens on the timescale of about 2 years of tropical winds. And although the tropics are very far away from the polar vortex, which is occurring really over the Arctic regions, we notice that when the winds in the tropics are easterly, or what we refer to as a negative QBO phase, that tends to be associated with a much weaker polar vortex in the northern hemisphere winter. And when we have these northern hemisphere polar vortices that are weaker than what we would typically expect, that gives us a much greater confidence that there's actually going to be one of these cold snaps, or a much higher propensity for having one of these cold snap events. So what we're seeing here is that in this red line, this is showing the historical quasi-biennial oscillation, and we're seeing this very obvious repetition in its pattern. And up until September of 2025, we see the red, and then this black line is the extension into the future. And highlighted in this blue box is showing the winter of this upcoming season. And what are we seeing? That this is going to be negative. So that's again going to mean that if we have a negative QBO, that's going to mean that we're going to have a weaker than average polar vortex, and thus a higher likelihood for some of these cold snap events. So the last slide that I want to show is just actually like what we can expect using the historical record for what the conditions are looking like for the upcoming year based on what the QBO is doing, as well as knowing exactly that this upcoming year is probably going to be in something like a neutral ENSO. So what is then the likelihood, or what's the characteristic temperature anomalies that are associated with that? So if we just composite all of the November to March months in the historical record from 1979 to 2024, and we look at what the temperature anomalies are associated with that when we have this negative or easterly QBO and neutral ENSO, what we get is something like what we're seeing on the right over here. So these are negative temperature anomalies which persist over the United States and Canada, and we also see strong negative temperature anomalies over northern Eurasia. So again, this is very consistent with this idea of when we have an eastward QBO or a negative QBO, especially when ENSO isn't really doing very much and it's in its neutral phase, that means that we're going to have a weaker than average polar vortex. And when we have that weaker than average polar vortex, we're likely to get these cold snaps, which either really bring down the temperature over Eurasia or start to bring down the temperature over North America. So this is being played out even in these composites that we're looking at over the recent years, or excuse me, over the historical record. So I think that that's pretty much everything that I wanted to say about the configuration of what this winter is going to look like and what our likelihood for having some of these cold snaps actually are. So hopefully that was enlightening on some level.
Thank you, Dr. Aden. That was super, super enlightening. And I wanted to also touch base on one more thing, which is that this winter is predicted to have a positive NAO sort of as the backdrop here. So, what that means is that the effect of these sort of cold snaps when they happen are going to feel even more extreme, just in the sense that, especially over the US and over Scandinavia, we expect warmer than usual conditions because of that NAO. And so when these cold snaps happen, you can imagine that they are just bringing in intensely cold air to an area that seemingly was experiencing a relatively balmy winter. So those are going to feel even more extreme when they happen, thanks to another element of the background fundamentals, which is the North Atlantic Oscillation. So please keep that in mind as well. So very cold, snappy winter with, this possibility of, these cold snaps that contrast a lot with how the background feels, which is going to feel possibly balmy in very many parts of the US as well as Northern Europe. So, continuing on, I just wanted to do a teeny review of the predictability that we have over the month of October due to the MJO. So, as we know, the QBO is in this eastward phase. When the QBO is in its eastward phase, the MJO tends to be pretty strong. When the MJO is strong, its teleconnections across the Pacific are also really strong. And the MJO is relatively predictable, and so we can use this as a very good subseasonal predictor, particularly this year, given the state of the QBO. And so, if we look at what to expect over October and early October and then mid to late October, what we see is over early October, something that looks like a lot of precipitation over South Asia and Southeast Asia with teleconnections that come into southern Mexico and Central America. And then as we move into the MJO phase one, going into phase eight, we see once again this kind of teleconnection that's going across the Pacific to southern Mexico and Central America being relatively strong. And in fact, that is what we see in our forecasts as well. So we think that this is a pretty robust signal, given that it is linked to this very predictable component, the MJO. So this right here is our prediction for precipitation over South Asia and Southeast Asia over October. And you can see just really, much wetter than usual conditions over this region. If we look at this sort of week by week, different areas are just getting sort of hammered weekly. Some of these areas actually are getting hammered week after week after week, and that starts to become a problem, particularly for agriculture. Crops can deal with a lot of rain, but if they are dealing with weeks and weeks and weeks of a lot of rain, then eventually their roots start touching the bottom of the or the top of the water table, and that's when you can have crop failures. So, and then of course, all of the industries that are in this area, as well as ports, can potentially be affected by this really strong end of season monsoon that we're expecting over these regions. Also, keep in mind that another factor that we think is coming into play here is that the Tibetan Plateau has had a lot of melt this past summer. So it is very warm right now. It is unseasonably warm over there. And so we think that that is probably another factor that's really driving this kind of very strong monsoonal circulation at what we expect to be the very end of the monsoon. So keep this region in mind when you look into October and where your assets may be located. And then from there, there's also a pretty strong signal from the MJO phase two that looks like it's being propagated across the Pacific to southern Mexico and to Florida. So this corresponds to these significantly wetter than usual conditions over southern Mexico and Florida. And these are regions where there is a ton of oil and gas refinery, transportation going on. And so keep that in mind as well in terms of potential areas where we might see some disruption in terms of some of our transport systems and some of our oil and gas systems as well. So, this brings us now to the very end of this seminar. Thank you so much for being here. And I just want to put in a quick plug about next week's seminar, which will be about the ski season. So, stay tuned for that. We're really excited to tell you about what ski season conditions will be like over different parts of North America and Eurasia. So stay tuned. And then, if you are interested in learning more about our models, about our products, and whether they could be useful to your trading decision making, please contact us, Hansi at planette.ai, or you can contact me on LinkedIn. And I regularly post on LinkedIn regarding the link between our changing climate, our changing weather patterns, and how this affects businesses and finance. So would love to, see you comment on some of these posts and engage. And yeah, would love to stay in touch in any way. So